Hey all, today we're doing stoichiometry. And it's a big, like, fancy word that just means you use it to calculate amounts in a chemical reaction. You know, like how many grams you need to weigh out or how much solution to use. But we're only going to do grams. What does an equation mean? So here's all of it. First off, particle level. A balanced chemical equation means two molecules of H2S plus three molecules of O2 makes two molecules of SO2 and two molecules of H2O. In real life, they wouldn't be separate like this. But visual, it's a balanced chemical reaction. So, these are the purple are the S's. So two S's over here, two S's over here, four H's, four H's, six O's total, two, four, six O's over here. So it's a balanced chemical reaction. But, so nobody's ever stoichiometry is how to weigh out stuff like in a lab. Baby, shh.
That's Minnie Mouse.
It does look like Minnie Mouse, doesn't it? Water looks like Minnie Mouse. You can't weigh out it's physically impossible to weigh out two molecules of H2S and three molecules of O2, but we can weigh out moles, right? Once you know the molar mass, you know the mass of one mole. So funnily enough, O is 16 and O2 would be 32. So whatever 32 times 3 is, that would be the mass of O2 that if you could weigh it out on the scale, you would have to weigh out. So the other example is just a different equation. This is the hydrogen peroxide equation. Hydrogen peroxide breaks down into water and oxygen. So the other idea of the balanced chemical equation is that everything, this perfect ratio, balanced chemical equation ratio, means everything is equal to each other. So you can read this, but I'm going to explain it. That means 2 moles of hydrogen peroxide makes 2 moles of water. 2 moles of hydrogen peroxide makes 1 mole of oxygen. But also, 2 moles of water and 1 mole of O2 are produced. So, everything's equal to each other. So when everything's equal, you can use them as fractions or, things in ratios like this. These would be parts of our railroad grid. And these could be top to bottom, bottom to top. So these are, the fractions, the conversion steps our conversion steps. But what this is called mole ratio. So it's the ratio of moles in the chemical reaction. And sometimes, here's another equation. If I just wanted to figure out what mole ratio is, AgNO3 to MgNO3, that would be 2 to 1, right? 2, 1. MgCl2 to AgNO3, that would be 1 to 2, right? And then AgCl to AgNO3, 2 to 2. You use the mole ratio, you use this mole ratio step. So before, when we did mole conversions, we just had one chemical, right? We just did one chemical. But now, we're going to start with this chemical over here and try to figure out how much of this is produced. So, you use it. The setup for that's when you switch between compounds. So the mole ratio, this mole ratio step is how you switch between chemicals in your reaction. So set up this, we never really did this number one. We never wrote off to the side what you're solving for, but it's really going to help with this stuff because you're looking for two different chemicals. Your given is always going to be in the question. The conversion step is just going to be that mole ratio, and then you multiply at the top, divide by the bottom and get an answer. So again, the most important thing is to know the mole ratio step is always mole. It's moles. The numbers in front stand for moles. And also, really, this should say, if it's just mole ratio, the bottom number is going to be the moles of the chemical you have, which is this one, and the top's always going to be what you're looking for. So funnily enough, that's actually what it always is. The bottom is always what you have. The top is what you're looking for. It is dark, baby. Okay, so again, there's just the steps and words. So here's our equation again. So just an example. So step number 1, what are we looking for? And for crying out loud, please read the whole question, but how many moles? Like, that's a question. So that's what you're looking for. You're looking for moles of AgCl. So I write that over here, mole AgCl. It's silver chloride. I probably should be using these guys' names, but sometimes it's easier to just say the letters. And what's our starting number? 3.7 moles MgCl, because it's a number and moles and like that. It's just your given, right? And then you draw your grid. And then what you have goes in the bottom, what you're looking for goes on top. So step 3, MgCl, that would be a 1 on the bottom because there's no number in front. On the top is what you're looking for, and that's your 2 AgCl, and it's 2 moles. And then the word, and I don't have anything that's I don't have anything that's crossing off the moles, but 3.7 times 2 is 7.4. Example number 2. Anna's talking on the phone. So again, next question, the equation from the beginning. So how many moles of SO2 will form from 0.75 moles of O2? So what are you looking for? Moles of SO2. Oops, I forgot to change the, crap. SO2. I think I changed these numbers. What are you looking for? The blue. Oh no, that's your starting. 0.75 moles O2. Dang it. I changed the numbers. And then the grid. I underlined the right things. The mole ratio is what you have. O2 goes on the bottom. So, nope, I didn't. 3 moles O2. And the top would be what you're looking for. SO2. Well, it is 2 moles, just the wrong chemical. SO2. Equal, and of course it's not 7.4, but 0.75 times 2 divided by 3. I don't actually know what that is because I forgot to fix this. I thought it was done. 0.75 times 2 divided by 3 is 0.5. So that would be 0.5 moles of SO2. So I'll totally just change all my labels for the slide that's going to be in the, PowerPoint, but now you know. I'll probably only have like 3 or 4 because the whole big problems are just going to be mole ratio step. So we're going to do this and then how to figure out how many grams are in the equation. So really this is a 2-lesson week. So yeah, we'll see you guys. I'll try to set up a Zoom meeting or something so I can actually see you, the few that are left. All right, good luck.